when one or more than one hydrogen form a hydrocarbon is being replaced by one or more halogen, a new molecule formed, we call it alkyl halide. So, in short, say a hydrocarbon like methane CH4, one of the hydrogen is being replaced by a chlorine atom. You get CH3Cl. This is your alkyl halide. Similarly, for benzene C6H6, one hydrogen is being replaced and then you get C6H5Cl, chlorobenzene. So these are the types of alkyl halide. Now look at this board. The types. Usually alkyl halide of monohalide, dihalide, trihalide. This depends on the number of halogen atoms that have substituted the hydrogen atoms. Another is if the alkyl group is of this type RCH2X, it is 1 degree. If it is RC R-X, it is 2 degree, and if it is RC R-R-X, it is 3 degree. So you can classify the hydrocarbon in the form of 1 degree, 2 degree, or 3 degree. Another type, allylic halides, benzylic halides. In both the cases, this is called allylic carbon. This is allylic carbon. What is the allylic carbon? Next to the allylic carbon, the carbon contains one double bond, sp2 bonding. This is sp3, but this carbon next to the allylic carbon contains sp2 hybridization. So these are allylic carbon. Similarly, here also cyclohexane. Another type is benzylic halides. Benzene ring, and there is extension with CH2 or CH3 toluene, and you got a substitution X here. So these are benzylic halides. And this is also, if this is CH3, this is CH3, this is CH3, these are 3 degree alkyl halide. So far we have discussed the carbon atom that contains the halide or halogen is sp3 hybridized. Now we will discuss carbon atom that contains halogen sp2 hybridization. They are known as vinylic halides, aryl halides. Now see, this carbon contains the halogen, again it is attached to a double bond. This is cyclohexene, that this X is attached to this carbon which is attached to the double bond. These are vinylic halides. Similarly, aryl halides. This is a benzene ring and there is direct replacement of X like chlorobenzene. So these are aryl halides. These are also aryl halide as because the carbon attached to the double bond also. Carbon contains the halogen attached to the double bond also. There are some special alkyl halides. We call it gem dihalide and vis dihalide. How is that? See, on my left, that is 1,1-dichloroethane. Two chlorine atoms are attached to the carbon, same carbon. They are known as gem dihalide. And in the right side one, it is 1,2-dichloroethane, vis dihalide. That means both the chlorine atoms are attached to the different carbon in the chain. These are special types of alkyl dihalides. Now let us solve in-text problems. Page number 163. Number 1. Item given 2-chloro-3-methyl pentane. So how to solve it? First you write 5 carbon in a chain, so it becomes pentane. Then at 2 position you put on chlorine, and in 3 position you put on methyl group. Hence you get it 2-chloro-3-methyl pentane. Number 2. 1-chloro-4-ethyl cyclohexane. First you draw a cyclohexane, and top of the position you give one chlorine, and exactly from here at 4th position you give one ethyl group. So you get 1-chloro-4-ethyl cyclohexane. 3. 4-tertiary butyl 3-iodoheptane. So you put 7 carbon in a chain, then you count 1, 2, 3, put on iodine, and 4th position you put on butyl, tertiary butyl. So your answer will be 4-tertiary butyl 3-iodoheptane. Question number 4. 1,4-dibromo-but2-ene. So first you draw 4 carbon and put one double bond in between second and third carbon. Position 1 carbon, it is bromine. So it is 1,4-dibromo-but2-ene. Question number 5. 1-bromo-4 secondary butyl 2-methyl benzene. Draw a benzene ring. At 1 position you put on bromine, 2 position put on methyl, and 4th position you put one secondary butyl. So that is your product 1-bromo-4 secondary butyl 2-methyl benzene.